Okay, this video is about solving quadratics. I've got to get my eraser handy. Get that computer situated properly. Got my marker here. Looks like there's plenty of ink. I hope. Yep, we're in good shape. All right, so quadratics. Ax squared plus bx plus c equals 0. I'm going to break them up into three types: type A, type B, and type C. Type A, we're going to learn how to solve those quickly using inverse ops. Type B, we're going to learn how to write those in product form. Notice I didn't say factor. I'm not sure factoring resonates with folks as to what's really going on. We're going to turn a sum into a product. This sum into the product, x times ax plus b. We're going to solve it for 0. And writing this product gets us an x equals 0 and an x equals minus b over a. And x equals minus b over 2a is what is the average of those two roots. And that has significance for quadratics. Minus b over 3a has significance with respect to cubics. Minus b over 4a has significance with respect to quartics. That continues on ad infinitum. I'm not sure the benefit past minus b over 3a, that's the x value at the point of inflection of a cubic. We'll have that discussion, I'm sure, as we move forward into cubics. But right now, we're dealing with the average of the roots. It's between 0 and minus b over a. In type C, we might use products. We might use inverse operations by putting these in graphing form, which is based on completing the square. And we might use the quadratic formula at different times. The easiest one to do depends upon the quadratic that we look at. And that's what I hope to have a little practice here. So we're going to type A first. Type A might be something like 2x squared minus 7. The geometric implications here are as follows. So x squared looks like it has to be 7/2. Because the 2's cancel and 7 minus 7 is 0. And x looks like it has to be plus or minus the square root of 7/2 because x stands for the square root of this square. Okay, so that's the geometry going on. All right, as far as graphical, this is one place I think transformations lends itself nicely to an explanation. So x squared is simply a cup-shaped graph, 1, 1, 2, 4, 3, 9, so on and so forth, negative 1, 1, negative 2, 2, negative 2, negative 2, 4, so on and so forth. So the symmetry. And then if you double it, what you're really doing is taking one y value and doubling it, right? Because you got to square before you double. So when we square, we get an altitude. 3 squared is 9, doubling is 18. All right, so that makes it a narrower parabola. And then when we subtract 7, we just take 7 units away from each y value. And if that y value is 0, then this becomes 0, negative 7. And we look at where this thing equals 0, which is the x-axis. So you're finding the x-intercepts. Okay, otherwise I don't use transformations to, state what I'm looking at with different graphs, because I think you're measuring square change from a different coordinate, and linear change from a different coordinate, and cubic change from a different coordinate, which happens to be the point of inflection. All right, so enough said about that. So now just the mechanics of this. Subtract 7 becomes addition of 7 on the other side. Multiplication becomes division, and squaring becomes plus minus square rooting. I don't think you have to rationalize that, but you can if you want to. If we did, nah, I'm not going to rationalize. That's it. Computers handle these now easily. So that's that answer. All right, so let's have another go at it. Let's look at minus 1/2 x squared equals negative 4. All right, so we're going to graph the original equation from the perspective given. And it was a negative 1/2. I've got some things written over there, so I don't have to think about what I want to ask you. All right, so what do we have? Well, we got minus 1/2 of something. Right, so that something looks like it's gotta be 8 units, right? Minus 1/2 of 8, so what's the square root of 8? Plus minus 2 root 2. Right, so there's the geometry of that. Minus 1/2 x squared is the squaring process. Now that's a little wider than x squared because each y value is being divided by 2, and we're going in the other direction. And minus 4 is an altitude below the x-axis, which happens to be y equals 0. Right, that's that x-axis, no height. All right, so we got 1x over here, and we got 1x over here. So we got the symmetry. All right, let's go find those values. All right, back to the original equation. So we're going to multiply that by 2, which makes it -8. That takes care of the division. We're going to divide by a negative, makes it +8. And then we're going to take the square root plus minus the square root of 8. And yes, I do think you should do plus minus the square root of 4 times the square root of 2, which is equal to plus minus 2 root 2, because trigonometry, you want to memorize root 2, right, which is approximately 1.41. Right, and if you double that, you're at approximately plus minus 2 times that, which is 2.82. So that's where those intersections occur. Okay, that's an approximation. Okay. I guess I wrote the plus minus twice. All right, so that's that one. And I think it's good to have a little feel for the graphical as well as the geometric. So 5x squared plus 10 equals 0. All right, so this whole thing has to equal -10. Right, we're gonna have -10 here. So that means that this is -10 for an area, which is, square root of 10i plus minus. And that's what's going to come out of this. Let's look at it from a graphical perspective. From a graphical perspective, we have a narrow parabola moved up 10 units. Okay, so if we move that up 10 units, we're here. And what this is really, the answers really are a sign change. Thinking about this turning over, and then we have an answer here and an answer here. Imaginary answers, but still a number that makes it work. So imaginaries are just numbers that make things work. All right, so let's look at it. What do we have to do to get to 0? We got to go down 10 units. I hope that tells you why that inverse operation is happening. We're multiplying by 5, so therefore we have -2 units of change. That takes care of that one and that one. And then we have the plus minus square root of -2, which is square root of 2 times the square root of -1. Remember what I is. I times I gets us -1. So I could have been written as the square root of -1. Okay, but it's easier to write I. So our answers are 2 plus or minus 2i. So let's put those in and see how it works. Plus minus and square, we're going to add 10, see what we get. Did I get the right answers here? So squaring plus minus 2, square root of 2i. Wasn't that what I was looking at? I believe you. Square root of 2i. Oh, that's where I made a mistake. Okay, good thing I checked. All right, so when you square plus minus, you get a positive. When you square square root, you get what's inside. We still have to square the I, and so that's what we have. I squared is -1 times 2 is -2 times 5 plus 10. There's our 0. All right, let me get a little hit of coffee here. Hopefully I don't make, oops, wrong cup. Hopefully I don't make a mistake again like that. Pretty hot. All right, we'll sip that for a while. All right, let's try another one. Let's hope my talking doesn't get in the way of my thinking about what I'm working on. So 1/5 x squared, where does that hit? -15. All right, from the perspective given, 1/5 x squared is up, it's going to be y parabola. Compared to the parent function, -15 down here. So what do we have to do? We gotta go down 15 units. We gotta multiply by 5. And let's see, that's gonna be that, right? Gotta go down 15 units. From here to here. So here's negative 15, all right. Multiplying by 5 and then taking plus minus square root, looks like it's gonna be plus minus the square root of 5 times 25, right? 3 times 25, sorry. 25 times 3, so the square root of 25 is 5 and 3. And it's magic. All right, so but let's just do, oh, that was good. Let's just do the mechanics. This glasses out of my left hand. All right, let's just do the mechanics of this. I feel like this is choppy video, but I'm not gonna do it again. All right, so division by 5, multiplication by 5. Boom, gone. Squaring, square rooting. So we got plus minus square root of negative 75. Take out the negative and call it imaginary. And there's our plus minus square root of 3 times the square root of 25. So let's put the 25 there and the 3 there. And then I hope you can see how you get plus minus 5 and 3 imaginary. All right. So that's that. Let's move to the products. Type B. Type B, something like, let's look at 2x squared minus 7, but let's put an x there. Okay. More coffee. Let's graph from the original. So 2x squared is a narrow parabola. Minus 7x is a line that's coming down. And we're putting these together and we're trying to figure out where we get 0. Well, this is a negative y value. This is a positive y value. And when you add them up together, we're going to get 0 somewhere in here. So one of our answers is going to be negative, one's going to be positive. It's easier, well, no, I'm not going to change. We're going to graph from the original. This was the original. I always take an x out. 2x minus 7 equals 0. So if all I was looking for were answers, my first answer is always going to be 0. My second answer is always going to be what makes it 0 here, which is 7/2. Okay, and that was our positive value that works in this situation. Okay, so if all I was doing was solving this, I always know I can take an x out. That allows me just to erase one x, and I can see the other answer as a shortcut. All right. Let's look at 1/2 minus 1/2 x squared plus 4x. Why do we look at the set from the original? So I better stick with it. So minus 1/2 x squared is this. 4x is a line looking like that. We've got the same situation. We need a positive y value here and a negative, so that when we add those up, we hit 0. All right, that's from the graphical. I always take an x out. So minus 1/2 x plus 4 equals 0. So there's one answer, automatic, so I don't ever have to deal with anything else. You know, you could have taken minus 1/2 x out, factored there. Might have made this a little easier, but you're gonna have to confront it anyway. So the inverse of addition is subtraction, the inverse of division by a negative is positive, and then we're doubling. So it's at positive 8. You might want to take more time with that. Minus 1/2 x plus 4 equals 0. So therefore, there's your negative 4, doubling it. There's your negative 8, hitting it with a negative, there's your positive 8. All right. And it doesn't hurt to plug an answer in like that when you're dealing with fractions. 8 squared, 64, cut in half, 32. So this is minus 32. And 4 times 8 is positive 32. And you can see those add up to 0. All right. So writing that as a product. You'll hear your teachers say factor. I'm going to keep saying write that sum or difference as a product, which is what factoring is. And factoring, God, I'm getting old. I hope I talked about minus b over a and 0 here. I think I did at the start. So type B, 5x squared plus 10x. We know one of our answers is 0. The other is get rid of an x, and you can see negative 2. Okay, if you were in a hurry. But let's look at it from the standpoint of 5x squared plus 10 equals 0 graphically. We've got a narrow parabola lifted up 10 units. All right, so there's your vertex. Our answers are going to be imaginary. I don't think I said that a second ago. I might have said something wrong here. So let's factor this. Oh, this was 10x. I went back to the other type A. So I was looking over there because all I did was put an X with the 10. So that's where I got confused. All right, so 5x squared narrow parabola, 10x. Boom. This time we got a negative answer on this side and a positive answer. A negative answer here gets us a positive y and a negative. When we put those together, that's going to get us our 0. Okay, so that's what I did. I went back to type A on the board, so we wouldn't have to think about making one of these up. All right, so we do a product, x times 5x plus 10 equals 0. All right, and so x equals 0, and my shortcut did find the correct answers quickly, but I forgot I was starting with this calculation for a second. All right, so 1/2 x squared plus 15x. 1/5 x squared plus 15x. And since I got myself in trouble here, I'm going to do 1/5 x squared equals minus 15x, and I'm going to look for the actual points of intersection. Okay, so points of intersection. Minus 15, linear function, 1/5 x squared, wide parabola. There's our first answer, 0, which we always get. And the other intersection is occurring up here on the left. So we're going to get a negative answer. And it looks like we got some real answers on this part. All right, so we got x times 1/5 x plus 15 equals 0. So there's our 0. And this one has negative 15 times 5, right? If we move that over and then multiply, so negative 75 is our second answer. And that was, should have been way over on the left with a very wide parabola. And I don't think I gave you a wide parabola. All right, so a bit of a choppy video here, but getting some reps in. We'll get plenty more as we go along. So type C, products, inverse operations, quadratic formula. If I had a problem like, and I'm not going to graph this at this point. All right, don't graph it. Just going to look at the mechanics and talk a little bit about what I would choose. So if I had 2x squared plus 20x minus 3, then I wanted that to equal 0. Well, if minus b over 2a is an integer, I'm going to put it in graphing. I think it's quicker than doing the quadratic formula. So minus b, minus 20 over 4, negative 5. Minus b over 2a equals negative 5. So now I know my answers are x values, negative 5 plus or minus something. All right, so I'm going to throw that in graphing form very quickly. Okay, there's the graphing form. Right, if they're both positive, I can just say positive there. I know. All right, so I should, by completing the square, have 50 units if I put a 0, and I got 50 units coming up. But I want minus 3 to come out if I put a 0. So whatever gets produced there, I got to get rid of it. So that 50 units has got to go away. So minus 53. And now I'm basically done. All right, because minus 53 becomes positive 53 divided by 2 on this side. I believe that's the case, so let's prove it. Minus 53 becomes 53. Multiplication by 2 becomes division by 2. Squaring becomes plus minus square rooting. And I'm measuring from negative 5. Okay, those are my x values. All right, so if I saw that I could put something in graphing form quickly and easily, might as well. Gets me some practice with graphing form. And we could do it by the quadratic formula as well. Products. All right, so products, it is helpful to know if b squared minus 4ac is a nice square root, right? If it's a perfect square, if b squared minus 4ac is a perfect square, then you're going to get rational answers. You're going to get integer answers, friendly answers. All right, so let's just try 3x squared minus 4x plus 5 equals 0. All right, from a graphical standpoint, I will graph this one. I'm starting at 5. I'm going down at 4 to 1, which means that I have a parabola that I don't know where it's bottoming out. Okay, so I'm going to look at minus b over 2a, 4 over 6, which is x equals 2/3, which means that it bottoms out pretty quickly. Therefore, I think we got imaginary roots here. And what's the best way to get them? I wouldn't put it in graphing form. I don't think I'd want to work with the fractions. But I would work with 2/3 now, since I already did that. And all I have to do is get 2a, excuse me. 2 times 3 was 6, so that was minus b, geez, I'm going too fast here. So 2/3, but this has to be a 6. So I don't know. I don't usually do this too often. So what's the best way? All right, let's just go for it. Minus b plus or minus, that's my rule. Seems like I'm talking without firm grasp at this instance. So let's just do it. Minus b, 4 plus or minus the square root over 2a, which is 6. So all we gotta get is b squared minus 4ac. So there's your 16 minus 4 times 3 times 5. I like to write those parentheses in so that you've got 16, 12 times 5 is 60, 16. So I think we have minus 54 in here. Okay, so the square root of 54i is what goes there. Seems awkward, but you know, you can estimate this, right? Estimate this, so 54 close to 64, and the square root of 64 is 8. So flat 4 plus or minus 8, 6, you know, 4 plus or minus 1, something like 3, and negative something small, -1, I guess, which makes some sense, right? So if you flip this over, boom, penny, boom, goody, yeah, those answers make some sense, I think. And then quadratic formula was helpful there. Let's see what else we got over there. X squared plus 8x minus 3. X squared plus 8x minus 3. I mean, this is just too simple. This is too simple to not use completing the square, which is good practice for you, putting it in graphing form. So we cut in half. All right, that should produce 16 units. I don't see it up here. Let's get rid of it. Minus 3 equals 0. All right, I think that would be the best way to handle this. And so therefore, we got minus 19 on that side. So we got plus minus the square root of 19, minus 4. And that just seemed too quick and easy to pass that up. All right, so 3x squared plus 8x minus 2. 3x squared plus 8x minus 2 equals 0. All right, so we got minus 2. We're starting at minus 2. We're going up at 8 to 1. And we continue to go up quicker. So we've got a parabola that looks like that. One of our x's is a small positive. The other is a bigger negative. And I guess we'd be working fractionally for putting it in graphing form. So let's just get back to the quadratic formula. So x equals minus 8 plus or minus the square root all over 2a, which is 6. We deal with simplifying it later. B squared, 64 minus 4 times a times c. Put the parentheses in, 3 and -2. All right, and we've got ourselves 64 minus 6 times 4, 24. So plus 24. So that's 88. So the square root of 88 is between 9 and 10 units. And we're subtracting 9 and 10 units from -8. So minus 18-ish, minus plus 2-ish, 6. So that's around a third. Okay, and we're centered at minus 4/3. So this is minus 4/3, and whatever that distance is, we're going back that distance. And we have some real roots. All right, so we've got to do a bunch of these. Got to do a bunch of these and kind of decide, you know, when we're gonna use factoring, you know, writing as products, when we're gonna use writing as products, when we're gonna use inverse operations. Type A, if you don't have a linear term, go right to inverse operations. Type B, if you don't have a constant, go right to writing products. Type C, get some experience as to which to use and when. But getting quadratics written as products is going to be a big part of our term, because you've got to be able to write products to simplify division. All right, so we're going to do a lot of, you know, 2x plus 3 times x minus 4. How to write this product would be 2x squared, 3 minus 8 minus 5x. This is how I make them up in class. And then I hide it and I go, okay, so how do you write that as a product without having to, you know, factor by grouping, that whole process? I don't think if the coefficient is this size, you absolutely know you've got 2x times x. And then you've got the factors of 12, 1, 2, 3, 4, 6, and 12, and their matches, which are 1, 2, 3, 4, 6, and 12, right? And if you put a 1 in, 1 and 12 don't get me anywhere near 5. You put a 2 in, 4 and 6, different combinations of 4 and 6. I don't see getting me a 5. If I put a 3 in, then it's 6 and 4. I'm not seeing that. If I put a 4 in, it's 8 and 3. Bang, you've got it. Okay, because when it's different coefficient, you gotta factor in, using that term, your product is 8, not 4. All right, and so therefore, we've got 8 and 3, which can make a 5, and we want it to be negative, so that gets to be the negative, that gets to be the positive. And then if we set this to 0, right, that means that b squared minus 4ac is a nice number. So if you run an SAT and you wanted to know if your roots were rational, irrational, or imaginary, you would quickly do b squared 25 minus 4 times a times c. And we got 8 times minus 12, which is negative times negative is positive. 8 times 12 is 96. 96 plus 25 is 121. The square root of 121 is 11. You got rational roots, 4 and negative 3/2. All right, so that gets us up and running with the various ways that you tackle quadratic equations. And had a few moments of, what am I doing? Talking too fast, but you're always pausing the video and then playing it so that these videos don't get to be 30 or 40 minutes long. All right, see you in class.